Why conduct structure equation modeling? Why is SAM popular? There are at least four major reasons for the popularity of SAM. The first reason suggests that researchers are becoming more aware of the need to use multiple observed variables to better understand their area of scientific inquiry. Basic statistical methods only utilize a limited number of variables which are not capable of dealing with the sophisticated theories being developed. The use of the small number of variables to understand complex phenomena is limited. For instance, the use of simple bivariate correlations is not sufficient for examining a sophisticated theoretical model. In contrast, in contrast, structure equation modeling permits complex phenomena to be statistically modeled and tested. SAM techniques are therefore becoming the preferred method for confirming or discontinuing theoretical model in a quantitative fashion. A second reason involves the greater recognition given to the validity and the reliability of observed score for measurement instruments. Especially, measurement error has become a major issue in many disciplines, but measurement error and statistical analysis of data have been treated separately. Structure equation modeling technique explicitly take measurement error into account when statistical analyzing data. As noted in subsequent chapters, SAM analysis includes latent and observed variable as well as measurement error term in certain SAM models. A third reason to how structure equation modeling has measured over the last 30 years, especially the ability to analyze more advanced theoretical SAM model. For example, group differences in a theoretical model can be assessed through the multiple group SAM model. In addition, collecting educational data at more than one level, for example, for students, teachers, and schools, is now possible using multi level SAM modeling as effect and interaction effects can be tested. These advanced SAM models and techniques have provided many researchers with an increased capability to analyze sophisticated theoretical model of complex phenomena, those requiring less reliance on basic statistical methods. Finally, SAM softwares program have become increasingly unfriendly. For example, until 1993, LISREL user had to input to program syntax for their model using Greek and matrix notation. At that time, many researchers sought help because of the complex programming requirements and knowledge of SAM syntax that was needed today. Most SAM software programs are Windows based and use pull down menus or driving programs to generate the program syntax internally. Therefore, the SAM software programs are now easier to use and contain features similar to other Windows based software packages. However, such ease of use necessitates statistical training in SAM modeling of software wise courses, workshop or textbooks to avoid mistakes and errors in analyzing sophisticated theoretical models. Structure equation modeling software programming. A researcher is just starting to use structure equation modeling software will find several new user-friendly Windows-based personal computer programs to choose from. Many of the new version provides statistical analysis of raw data, means correlation, missing data, conventions, etc. Provide routine for handling missing data and detecting outliers, generates the program syntax language diagram, the model, and provide for import and export of the data and figures of the theoretical model. Also, many of the program come with set of the data and program example that are clearly explained in their user guides. Many of these software packages have been received in a structure equation modeling journal. The pricing information for structure equation modeling software varies depending on individual, group, or sites, lessons, arrangement, cooperative versus educational settings, and even whether one is a student or a faculty member. Furthermore, newer version and update necessitate changes in pricing. Most programs will run in the Windows environment. Some run on MacBook, personal computers, EOS. We are often asked to recommend it a software package to a beginning SAM researcher. However, given the different individual needs of the researchers and the multitude of different features available in these programs, which also change with each version, we are not able to make such a recommendations. Ultimately, the decision depends upon the researcher needs and preferences. Consequently, with so many software packages, we felt it important to narrow our examples in the book to three: Amos, EQS, and LISREL. These three SAM software packages are available as follow. Amos SPSS interface developed by Dr. James R. Buckley, Department of Psychology, Temple University. These are the information about the software. EOS developed by the Peter, and the LISER it's developed by the Joxcom and Dan Sorbonne. Summary. In this chapter, we introduced structure equation modeling by describing basic type of variables: latent, observed, independent, and dependent, and basic type of SAM model: regression, path, confirmatory, factor, and structure equation model. In addition, we gave a brief history of the structure equation modeling and discussion of the importance of the SAM. The chapter concludes with the information about where to obtain the structure equation modeling software program used in the book. In chapter 2, we consider the importance of examination data for issues related to the measurement level, nominal, ordinal, internal, or ratio, restriction of range fewer than 15 categories, missing data outliers, extreme value, linearity or non-linearity, and normality, which affect all statistical methods and especially SAM application. Exercise. Define the following terms: latent variable, observed variable, dependent variable, and dependent variable. These are the questions. Let's talk about define the following term: latent variable and observed variable. Yeah. So here is some definition of the exercise. We'll talk. The first is the latent variable, and what is the latent variables? It is the unobserved variable that is not directly measured, but it is compute using the multiple observed variables. If we talk about the observed variable, a raw score obtained from a test of measurement instrument on a trait of the interest. Dependent variable, a variable that is measured and related to outcome, performance, or criteria. Independent variable, a variable that define mutually exclusive categories, for example gender, region, or grade level, as a continuous variable, influence, or dependent variable. Explain the difference between the dependent and latent variable and a dependent observed variable. A dependent latent variable is not directly measured, but it is computed using the multiple dependent observed variable. Dependent observed variable is a raw score obtained from the measurement instrument or assigned to a certain variable. Explain the difference between an independent latent variable and the independent observed variable. An independent latent variable is not directly measured but is computing using multiple independent observed variable. An independent observed variable is a raw score obtained from the measurement instrument or assigned to an attribute variables. List the reason why the researcher would conduct the structure equation modeling. Number 1, researchers are becoming more aware of the need of use multiple observed variable to better understand their area of the scientific inquiry. The second, more recognition is given to the validity and reliability of observed score from measurement instrument. Number 3, Structure equation modeling has improved recently, especially the ability to analyze more advanced statistical model. And number 4, SAM software program has becoming increasingly user friendly. These are the some websites where researchers can download their softwares. Chapter 2, data entry and data editing. These are the information. So we'll talk about the chapter 1 first, and then we'll discuss the chapter one by one. So here is the one chapter. Let's we read some references also there. So chapter 1, introduction. These are the references. We already completed the chapter 1, so here we have to discuss the chapter 2, and these are the some questions answers. Suppose independent variable, a variable that defined mutually. These are the answers. So define the following items. So we'll start from here. Define the following terms: latent variable, an unobserved variable that is not directly measured but it's computing using multiple observed variable. Observed variable, a raw score obtained from the test or the measurement instrument or the trait of the interest. Dependent variable, a variable that is measured and related to outcome, performance or criteria. Independent variable, a variable that define mutually exclusive categories, that is gender, reason or grade or continuous variable influence depending variable. Explain the differences between the dependent latent variable and the dependent observed variable. A dependent latent variable is not directly measured but is computing using multiple dependent observed variable. A dependent observed variable is a raw score obtained from the measurement instrument of assigned to the criteria variable. Explain the differences between an independent latent variable and independent observed variable. An independent latent variable is not directly measured but is computing using the multiple independent observed variable and independent observed variable is a raw score obtained from the measurement instrument of assigned to an attribute variable. A list the reasons why a researcher would conduct the structure equation modeling. Researchers are becoming more aware of the need to use multiple observed variables to the better understanding their area of the scientific inquiry. More recognition is given to the validate and the reliability of the observed score from the measurement instrument. Structure equation modeling has improved recently, especially the ability to analyze more advanced statistical model. Some software programs have become increasingly user-friendly. These are the list where the student can download the study material. Chapter 2, data entry and data editing issues. So, restrictions or range. What are they? A set of scores that are restricted in range implies reduce the variability, variance and covariance of the importance in statistical, especially correlation. Missing data. What is this? This is a set of the score which missing data can be affected the estimate of the mean of the standard deviation. It is important to determine whether the missing data are due to the data entry error, are the missing at random, or are the missing systematically due to the some other variables. For example, age, gender, outliers. A set of score with an outlier extreme score can affect the estimate of the mean and standard deviation. It is important to determine whether the outlier is an incorrect data value due to the data entry error, represent another group of the person, or potentially require the researcher to gather more data to fill in between the range of data. Non-linearity, researchers have generally analyzed relationship in the data, assuming linearity is a requirement for the Pearson correlation coefficient. Consequently, a lack of linearity that is not included in the statistical model would yield misleading result. Normality, skewness of lack of systematic in the frequency distribution and kurtosis, the departure from the normal distribution affect in, infantile statistics, especially the mean, the standard deviation, and correlation coefficient estimate the data transformation, especially a probit transformation can help you yield a more normally distribution set of scores. Chapter 3, Correlation. Chapter 4, SAM Basic. Model specification. What is this? This is the developing of the theoretical model to the test based of all of the relevant theory, research and information available. Model identification, determining whether the unique set of parameter estimate can be computed given the sample data contained in the sample covariance matrix S and the theoretical model that produce the implies population covariance matrix. Model estimation, obtaining estimate for each of the parameters specified in the model that produced the implies population covariance matrix sigma, the intent into obtain parameter estimate that yield a matrix as close as possible to our sample covariance matrix of the observed or identifiers variables when element in the matrix of minimize of element in the matrix sigma equal to 0, and then indicating a preference model fit to the data all variable are equal to values in sigma. Model testing, determining how well the sample data fits the theoretical model. In other words, to what extent is the theoretical model supported by the obtaining sample data. Global omnibus test of the fit of the model are available as well as the fit of the individual parameter in the model. Model modification, changing the initial implies model are restricting the global fit and individual parameters in the new, especially the model to determine how the modify the model that are a number of procedure available to guide the adding of the dropping of the path in the model so that alternative model can be tested. The correlation matrix has three variants in the diagonal and three covariants is the off diagonal of the matrix. So there are six distinct values from the three observed variables. How many distinct values are in a covariance matrix for the following variables? 5 variables, 15 distinct value, 10 variables, 55 distinct value. A saturated model with p variables has p plus 3 upon with 2 free parameters. Determine that number of free parameter for the following number of variable in a model: the 3 observed variable, 9 free parameters; b 5 observed variable, 20 free parameters; c observed variable, 65 free parameters.